All right, section 6.6, optimizing problems 3, linear programming. Linear programming is basically maximizing or minimizing questions. They are used, from what I could tell, like I took a course in this in university in 4th year, and it's used for if you have a whole bunch of constraints and you want to maximize your amount of time or something like that. Our teacher had told us a story about bus schedules and how people that, and I think it was in Vancouver or Toronto or something, where the bus schedules are crazy and they had to optimize and they had a whole bunch of different routes, and this was used to optimize. You do them in 2 variables. You have x comma y, which gives you a grid. In university, we had one, I think it was about 16 variables, so A, B, C, D, E, F, G, all the way across. We had to do them by hand, well, that question by hand. It took us about 4 or 5 hours, I think, for one question. So I'm not giving you those questions, none of those. So we'll keep it simple. So to test for an optimal solution, basically what you want to do is you want to check for your extreme boundary points in your region. So in this region this is taken from your book on page 341. Your extreme points are 0, 5, 8, 5, 0, 0, whoops, and 3, 0. And what you want to do is you want to check each one of those in your objective function. So I test them. G is equal to 2. My x value is 0. Plus 5 times my y value of 5. 2 times 0 is 0. Plus 5 times 5 is 25. 8, 5 I check. 2 times 8 plus 5 times 5. Again, I'm checking my x value is 8. Y value is 5. 16 plus 25 is 41. Next one. G is equal to 2 times 0 plus 5 times 0 is equal to 0. And the last one, G is equal to 2 times 3 plus 5 times 0 is equal to just 6. Once you finish that, you can tell right away what your maximum and what your minimum points are. So my maximum point occurs when x is 5, x is 5 and x is 8 and y is 5. My minimum point occurs when x is 0 and y is 0. So that's how to test points, your boundary points in your objective function. Optimization model. So for optimization models, they usually give you some constrictions or restrictions and constraints. So your restrictions are, okay, only whole numbers are allowed. That's good. Most of these are either whole numbers or integers or real numbers. And there's a few constraints here. There's c is greater than 0, m is greater than 0. I'll use a red for that one. So I already have that on my graph, right? I've constrained c, everything above, and m, everything above. So I have only positive values for both c and m. Good, done. Next one I have is this one here. Now this constraint here, I'm going to use what's called the intercept method. The intercept method works like this. I take a value of 0 and I plug it into c, and I figure out what my m value is. So if I plug a 0 into c, that means that is gone. And that means I'm just left with 6m, change this to an equal sign, or think about it like an equal. 6m equals 48. So divide by 6, 8. M would be 8. Next one I do is I plug a 0 into the m value. So it's like that one's gone. So if I plug a 0 in there, then I solve for c. 4c is equal to 48, which means c has to be equal to 12. So this gives me my 2 intercept points at 0, 8, which is up here, and at 12, 0, which is over here. Once I have those 2 points, I can actually connect them with a straight line, and I have my first line. So that's graphing using intercepts. Plugging a 0 into one of the things and solving for the other variable. Plugging a 0 into the other one and solving for the first one. My other 2 constraints are This one here, C is less than or equal to 12. So here's the C axis, here's 12. So I'd put a straight up and down line at 12. And I know that it's going to be everything to the left of that line because it's less than. Done. And my last one is M less than or equal to 4. So I go on my M axis, I find 4, and I put a straight horizontal line. And I know that it's got to be everything less than that line. Now it's kind of unclear as to which region am I talking about. Well, I know it's got to be below the purple line. I know it's got to be to the left of the yellow line, but I can guess that it's going to be below the green line based on the less than or equal to, but you can't always assume that. Because if one of these is minus, then it's going to change everything. So I kind of have to check. So I'm going to test the point 0, 0 in 4c plus 6m less than 48. So I get 4 times 0 plus 6 times 0 less than or equal to 48. Yeah, because 0 plus 0 is less than 48. 0 is less than or equal to 48. Therefore, I'm talking about this region in here. Because it's whole numbers, I only use dots. You don't have to actually fill these in. You're just actually concerned about where your region is. And once you know where your region is, then you want to figure out where your boundary points are in that region. And your boundary points are all the extreme points that that are in that region. So I have one here at, at 0, 4. I have one here at 6, 4. I have one down here at 12, 0. And then my last one is right here, which is 0, 0. Hopefully you understand that those are your boundary points. They're along each line and they're along the edges of your boundary. Next thing I have to do is I have to check them in my objective function. My objective function this time it gives me is v equals c plus m. These are nice questions because they give you all the constraints. You just have to graph the region and figure out where your boundary points are and then plug them into your objective function. So I have 0, 4. I have 6, 4. I have 0, 0, and then finally 12. And I just have to check them to see which one's my max and which one's my min. So, first one, v is equal to 0 plus 4, which is 4. Next one I have is 6 plus 4, which is 10. This one is an easy objective function. Next one I have is 0 plus 0, which is 0. And the last one I have is 12 plus 0, which is 12. So I can see right away, okay, my max and my min. So my max a point occurs at 12, 0, which is this one here. And my minimum point occurs at 0, 0, which is what I thought, which is this one down here. So that's testing your constraints and testing to see which what gives you your max and what gives you your min. Final example. This example we're going to have to come up with the constraints based on a word problem. So these are the toughest type of questions. You have to come up with the constraints, then you have to graph them. So the example is taken right out of the book, and it's Ed found spiders and crickets in his storage room. If I found spiders and crickets in my storage room, I would probably run and grab the vacuum because I don't like to touch spiders or crickets or bugs. So, and neither does my wife, so we both grab the vacuum. There were 20 or fewer crickets. 20 or fewer crickets. First constraint. So that means if I'm going to pick C for crickets, which is a good idea, 20 or fewer, less than or equal to 20. 20 or more spiders. So spiders I'm going to use S, 20 or more, greater than or equal to 20. First two constraints. Done. Next one. There are 45 fewer crickets and spiders in total. This one might be a little more difficult to figure out. 45 or fewer crickets and spiders in total. So this means that, or fewer means that my crickets and my spiders in total, C plus S, means that there's going to be 45 or fewer, less than or equal to 45. Crickets and spiders in total. Crickets plus spiders is less than or equal to 45. So I have my three constraints. What's implied though? Well, it should be implied that C is greater than or equal to 0 and S is greater than or equal to 0. You can't have negative crickets or negative spiders, so you have to have them both greater than 0, and that's what are called implied constraints. Next thing I have to do is my objective function, and that's given to me right here. Spiders have 8 legs and crickets have 6 legs. And the question says what combination of spiders and crickets would have the most number of legs and the least number of legs. So I'm dealing with legs here. So my objective function is going to be dealing with the number of legs is equal to, there's 8 legs for each spider, 8 legs for every one spider I have, plus 6 legs for every cricket. So to come up with an objective function, you have to kind of read through and figure out what is my function going to be, what is this equation going to be, and you should kind of be, this should be similar to what you've done in Math 10. A lot of this stuff is straight from Math 10. So I have all my constraints and I have my objective function. Now I can finally graph this. Okay, so my constraints are C is less than or equal to 20 and S is greater than or equal to 20. So 20 on both axes. I have a line at 20 here, straight up and down. And I have another line at 20 here, straight across. And I know that it's less than or equal to my C1, which is this one. And it's going to be greater than or equal to my 20. So it's going to be above here, but to the left of here. So I know right away it's in this region right here. Next thing I have to do is this constraint. So C plus S is less than or equal to 45. Again, I'm going to use my intercept method, because it's a lot faster than changing this to y equals mx plus b form. So my intercept method, and this is straight from grade 10 too, I plug a 0 into C, and then I get S is equal to 45. This one's easy. Then I plug a 0 into my S, gone, C is equal to 45. See how fast that was? So both my constraints are at 45. 45, I have my 2 points, get a ruler, and connect those 2 points. Now that they're connected, I need to figure out where my region is. Okay, well, let's see here. It's got to be less than this line, it's got to be greater than this line, and it's got to be less than this point. Well, I think it's in this region here, but again, you have to kind of check a point just to test, right? So let's pick the point right here. Let's pick this point here. So it's 0, 25. So 0 plus 25 is 25. Is that less than or equal to 45? Yes. So my region is here. That means my boundary points are going to be here at 0, 20, here at 0, 45, here, which is at 20, 25, and finally here, which is at 20, 20. And you can check to see, do those boundary points make sense with all your constraints? 0, 45. That means that I have no crickets and 45 spiders. Am I allowed to have no crickets? Yep, because it says less than or equal to. And am I allowed to have 45 spiders? Yep, because it's greater than or equal to 20. So 45 is fine. What about this one? 0, 20. No crickets? Yep, that's fine. 20? Yep, I can have at least, I need to have at least 20, but it can be equal to 22. That one, 20, 20? Yep, they both can be equal to 20, right? Equal to 20, equal to 20. Or 20, 25. So 20 crickets and 25 spiders. That's a lot of crickets and spiders. So 20 crickets, that's fine because it's equal to. 25 spiders, yep, that's fine because it's greater than. So all my constraints make sense for my boundary points. Next thing I do is I just have to test these in my objective function, which we've done before. So I take the point 0, 45, and I plug it in. I get 8 times 0. Whoops, I should change my objective function to be 6. C plus 8S. Just because then it's going to make more sense for me when I'm plugging in my numbers. Because you have to remember that this is my C value and that's my S value. So if I plug it C, I mean you could have done the other way too, but it's a bit easier this way. Because my C values first, S value second. So I get 6 times 0 plus 8 times 45 spiders. So every spider has 8 legs, right? So 45 times 8, I can't do that in my head, 360. So I get an answer of 360 legs. Wow. All right, next one. Let's do 0, 20. Down at the bottom there. So I get 6 times 0, which is 0, plus 8 times 20. 8 times 2 is 16, so that's going to be 160 legs. Oh, it's way less. My next one is going to be 20. So 20. I get 6 times 20 plus 8 times 20. I already know 8 times 20 is 160. I know 6 times 20, 6 times 2 is 12, so that's going to be 120. 280. That's more, but not quite as much as the 45 spiders. And the last one I get is 20 and 25. So 6 times 20, whoops, plus 8 times 25. So 6 times 20 is 120, we already know that. 8 times 25 is 200, plus 120 is going to be 320. All right, so right away I can see my maximum and my minimum. So I would say that there would be 0 crickets and 45 spiders gives the max. And then I could say that 0 crickets and 20 spiders gives the minimum number of legs. And that's how you solve for constraints. So just be sure that you know how to plug your boundary points in. Be sure that you know how to come up with constraints based on words, a problem, and make sure that you can test your boundary points, plug them in, and come up with your maximum or minimum values.